Good morning, students. Today we are going to learn Midpoint Theorem. This is a new chapter for grade 11 students of you. The Midpoint Theorem. This is related to a triangle theorem. In a triangle, there are three sides. In that triangle, the midpoints of any two sides of the triangle, the line joining the midpoints of any true triangle is parallel to any two sides of a triangle is parallel to third side of the triangle and half of length of the third side. The midpoint theorem is a result related to the lengths of the sides of a triangle. Okay, this is a theorem related to length of sides of triangle. Look at this triangle ABC. In here, P is midpoint of side AB and Q is midpoint of side AZ. That midpoints, the two P and Q are the midpoints of two sides. P and Q are the midpoints of two sides. AB, midpoint of AB and AC. Okay, the line joining the PQ, points PQ, is parallel to the third side BC and also half of the length of the third side. Okay, so we can write in triangle ABC, in triangle ABC, AP equal PB, or P is midpoint of AB. P is midpoint of AB, and next Q is midpoint of AZ. So now we can say, according to the theorem, the line joining the midpoint of the two sides of triangle, the line midpoints PQ, the line joining the points P and Q, PQ parallel to third side BC, parallel to the third side of the triangle BC, and length of the PQ is equal to half of the length of BC. BC means third side of the triangle. Okay, the length of PQ is half of length of BC and parallel to the BC, parallel to the third side. Theorem: the straight line segment through the midpoints of two sides of a triangle is parallel to the third side and equal in length of half of it, half of the third side. Okay, this is the midpoint theorem. Shortly, we can say the line joining the midpoints of two sides of a triangle is parallel to the third side and half of the length of the third side. Okay, now we see the proof of this theorem. Okay, now I am going to do the proof of this theorem, and then we do the exercise related to this. In the proof of this theorem, look at the picture. There is a triangle ABC and midpoints. Midpoints of AB, midpoint of AB equal P, ABP, and midpoint of AC Q. okay, and the line joint, PQ joint. Let's prove this theorem. First we have to write the data. In proof there are some structure. First we have to write the data. Data means the informations given in the figure, in the theorem. The midpoints in the, look at the figure, the midpoints of AB and AC of the triangle are P and Q. So we can write the midpoints of the sides, midpoints of the midpoints of the sides AB and AC are P and Q. P and Q. Okay, the midpoints of the sides AB and AC are P and Q. Next we have to write the to be proved. To be proved. In here we write the what we need to prove. What we need to prove: PQ parallel to BC, PQ parallel to BC, and PQ equal to half of the length of BC. This is we have to prove. In here, to prove this two conclusions, we have to draw a construction. We have to make a construction. So next we have to write that. Before that, I am going to do the construction. In here, draw a line, extend the line PQ, extend the line PQ, and draw a line parallel to AB through C, both are meets at R. These two lines meets at R. Meets at R. This is named as R. Okay, let's write the construction. Construction: draw a straight line through C, draw a straight line through C, parallel to A, B, B. parallel to AB. Now we have to prove this theorem. Proof. To prove this, first we have to plan how to prove this PQ parallel to BC and PQ equal to half BC. There are two small triangles, APQ and QCR. QCR. If we prove these two triangles are congruent, then we can say PQ equal to QR. PQ equal to QR, corresponding elements of congruence triangles. First we have to prove these two triangles are congruent, then we can say PQ equal to QR, corresponding elements of congruence triangle. And we can say AP equal to CR. AP equal to CR, this is also corresponding elements of congruence triangle. PA equal to CR and PA equal to PB. PA equal to PB. So we can say CR equal to PB through axiom. Okay, CR equal to PB. CR and PB are the opposite sides of parallelogram PRCB. Already we draw this. These are parallel side, PB parallel to CR according to the construction. So opposite sides of a quadrilateral equal and parallel, then we can say this quadrilateral is a parallelogram. So PRCB is a parallelogram, then we can say BC parallel to PR, opposite sides of parallelogram. If BC parallel to CR, we can say PQ parallel to BC. That we have to prove first, then do the next. So first I am going to prove AB triangle APQ parallel to QCR. Triangle APQ parallel to QCR. Triangle APQ parallel to QCR. Triangle APQ parallel to congruence to QC. Okay, sorry. Okay. In triangle APQ and QCR, AP equal, AQ equal, but AP equal, we can prove these two are congruence. Which case we can use? We can use the case angle side, no? Angle side. So corresponding angles equals. These two are equal. corresponding angles, and this angle and this are equal alternate angles, AB parallel to CR. Okay, alternate angles AB parallel to CR. So we can prove through angle side. First, PAQ equal angle PAQ equal angle QCR. Alternate angles. AB parallel to CR. AB parallel to CR. Like this. Another one, next angle AQP equal angle AQP equal angle QCR. Vertically opposite angles, you know. Vertically opposite angles. Okay, next side AQ equal CQ. AQ equal CQ given data. Given, so triangle APQ congruence triangle QCR angle side. Okay, these two triangles are congruent. Through this we can say PA equal CR. PA equal CR. Please be muted. Mute பண்ணிட்டு கதைங்கோ. In the figure we can say PA equal to CR. PA equal CR. Why? Corresponding sides of congruent triangles, and already given that AP equal and AP equal PB, sorry, PA equal PB, because data given a midpoint of AB, so PA equal PB given. Through axiom we can say CR equal PB equal CR axiom. Okay, PB equal CR. Now PB equal CR and PB parallel to CR, because construction we made the construction, draw a line through C parallel to AB, so PB parallel to CR. PB parallel to CR construction. PB parallel to CR construction. Okay, in the quadrilateral PC, in the quadrilateral PRCB, opposite sides, PB equal CR and PB parallel to CR. In a quadrilateral, opposite sides are equal and parallel. We can say that is a parallelogram. Therefore, PRCB is a parallelogram. So, in a parallelogram, opposite sides are parallel. So, through this, we can say, look at the picture. In the parallelogram PCBR, in the parallelogram PRCB, parallelogram PRCB, PR, opposite sides PR and BC are parallel. We can say, already we proved this is a parallelogram, so BC parallel to opposite sides parallel, BC parallel to CR. Okay, if BC parallel to CR, we can say PQ parallel to BC. From this, BC parallel to CR, opposite sides of parallelogram. Sides of a parallelogram. Okay, opposite sides of a parallelogram. So, BC parallel to PQ. PQ is a part of CR. So, BC parallel to PQ. One thing proved. Next, we have to prove PQ equal to half BC. PQ equal to half BC. Look at the figure. AP in this figure, in these two triangles are congruent, so we can say PQ equal QR. PQ equal QR. Corresponding elements of congruence triangle. PQ equal QR, corresponding elements of congruence triangles, but PR equal BC. PR equal BC, opposite sides of parallelogram. So, these two are equal. We can put PR equal to PQ because Q is the midpoint. PQ equal to PR. We can put BC instead of PR. So, PQ equal to half BC. Okay, let's prove. First, I am going to say BC equal PR opposite sides of a parallelogram. BC equal PR. BC equal PR, opposite sides of a parallelogram. Okay, BC equal PR. We can write instead of PR PQ plus QR. We can write instead of PR PQ plus QR. You can understand from the picture PR equal PQ plus QR. So I written instead of PR PQ plus QR. Okay, but PQ equal QR, but PQ equal QR, but PQ equal QR. Why? These two are the corresponding sides of the congruence triangle. So corresponding sides of the congruent triangles. Okay, corresponding sides of the congruence triangles. PQ equal QR. We can write BC equal PQ plus QR. So PQ equal QR, so we can write 2PQ. PQ plus QR equal to PQ. So now we can say, take 2 to the left sides of the equation. Half BC equal PQ. PQ equal half BC. This is the second one we proved. Already proved another one. BC parallel to PC. These two are the conclusion from this midpoint theorem. Okay. First we proved BC parallel to PQ, then PQ is equal to half of the length of BC. So everyone look at your books. There is this proof is in your book, so you can observe that and understand through the book also. Let's we move to the exercise. Exercise 11.1. Through this we can, according to the midpoint theorem, using the midpoint theorem, we have to find this, what you have been asked in the question, determine the value of x in each figure. So using the midpoint theorem we have to find the value of x. Okay, let's try this. In the first figure there is a triangle ABC. D is the midpoint of AB, E is the midpoint of AZ. So we can apply the midpoint theorem here. The line joining the midpoints of AB and AC are DE. the D line is parallel to the third side BC, and also DE, length of DE is half of the third side, half of BC. So we can write DE equal half of the BC, half of BC according to the midpoint theorem. Midpoint theorem. Okay, according to the midpoint theorem. So DE equal to half BC. We know the value of BC, that is given, that is equal to 15. So half into BC equal 15. So half into 15, 7.5. So D equal, D is X. So X is equal 7.5 centimeter. Okay. Look at the second one. In the triangle ABC, E and D are the midpoints. The length of the line joining the midpoint ED equals 6 centimeter is given. You have been asked to find the length of the BC, X. So we can write, according to the midpoint theorem, we can write BC equal half of ED. Half of ED. The length of ED is given. BC equal X, so X is equal ED equal given. Sorry, BC equal yes. BC equal 2 ED. 2 ED. BC equal to ED. We can write ED equal half BC, or otherwise BC ED equal half BC, or otherwise we can write BC equal to ED. Both are same, no? BC equal to ED. So BC equal X and ED given 6 centimeter. 2 into 6, 12 centimeter. X is equal to 12 centimeter. Look at the third one. There is a triangle LMN. Midpoint of LN is P and MN is Q. The length of the line joining PQ is given 2x minus 1, and third side LM is given 42. So according to the midpoint theorem, we can write the length of PQ equal length of PQ equal length of PQ equal half LM. Midpoint theorem. Okay, midpoint theorem. PQ is given 2x minus 1, 2x minus 1, and also LM given 42, half into LM 42. Okay, 2x minus 1 is equal to half into 42, 21. So 2x is equal, take minus 1 to other side, it becomes plus 1, 21 plus 1, 2x is equal to 22. From this, x is equal to x is equal to 11. Okay, 11 centimeter. Okay, these are the 3 simple examples for midpoint theorem and related that questions. I think everybody understand. Now move to the next question. Look at this. In the given figure, x, y and z are the midpoints of the sides mn, nl and lm. Midpoint of ln is y and midpoint of mn is x and midpoint of ml is z. So these two are equal. So 3 midpoints of 3 sides x, y and z, that is given. If mn equal 8 centimeter, and nl equal 10 centimeter, and also lm also given, that is 12 centimeter. So length of 3 sides are given. You have been asked to find the perimeter of the triangle XYZ. So we have to find the, yes, tell. We have to find the perimeter of the triangle. So first we find the length of 3 sides separately, and then at these 3 sides we can find the perimeter. So look at this. This length ZY, according to the midpoint theorem, the length ZY equal half of the third side MN. Okay, ZY equal half of MN from midpoint theorem, no? Midpoint theorem. Yes, tell. No doubt. So half into mn 8 centimeter, half into 8 4 centimeter. Okay, ZY equal 4 centimeter. Then XY, length of XY equal half of the length of XY equal half of the length of ML. Okay, according to the midpoint theorem. So we can find the XY by substituting ML equal 12, that's given. So 2 into 6 centimeter. Okay, XY equals 6 centimeter. Another side XZ have to be found. XZ, this is XZ. Okay, XZ equal half of the ln, half of ln. Okay, x and z are midpoints of the sides mn and ml, so length of the xz is half of the third side nl according to the midpoint theorem. Okay, so ln is given, that is equal to 10 centimeter, so xz equal 5 centimeter. Okay, now we know the length of three sides of triangle xyz. We have been also asked to find the perimeter of the triangle xyz. So perimeter of triangle xyz equal perimeter of triangle xyz is equal to sum of the length of three sides xy plus y z plus xz. xy is equal to 6 centimeter plus yz is equal to 4 centimeter and also xz is equal to 5 centimeter. So 15 centimeter. Perimeter of triangle xyz is 15 centimeter. Look at this. First, what is the perimeter of MLN? Perimeter of MLN is equal 12 plus 10 plus 8. Perimeter of larger triangle MLN is equal 30 centimeter. The xyz is obtained by joining the midpoints of the triangle LMN. The perimeter of the inner triangle is become half of the perimeter of LMN. This is 30 centimeter, half of this 15. You also obtained on the perimeter of triangle xyz is 15 centimeter. Okay. If any question come in first part, you can write straight away. Write the perimeter of xyz, half of the perimeter of MNL and half into 30, 15 centimeter. No need to do these methods in the first part. Okay. Okay, students, we finish this class. Now you do the questions in this exercise in your textbooks. Do the third and fourth question. We see this in next class. Until then, thank you joining with us.